Hi, today we're going to talk about how to solve equations, one-step equations, using addition or subtraction. Technically, we're really always adding, but let's take a look at a couple of examples first. Okay, your goal here is to solve an equation by getting the variable alone, or another word that I use is I isolate the variable to one side of the equal sign, and it doesn't make a difference which side. Use the inverse operation to isolate the variable, and that's key. So let's take a look at example 1. X plus 6 equals 4. And I'm going to just run through a bunch of things. So when I talk about which side of the equation, I'm referring to the equal sign. The equal sign is what makes it an equation. So which side of the equal sign is the variable on? It's on the left. What is it attached to? A positive 6. The inverse of a positive 6 is a negative 6. So that's what I want you to focus on. This is what we're talking about, addition or subtraction. Okay, but I'm looking here as x is attached through addition to a positive 6. The inverse of a positive 6 is a negative 6. There's those zero pairs. They cancel each other out, leaving you with x. And that was your goal, to isolate the variable and get it alone. Now, it's all about balance in math, okay? Whatever I do to one side of the equal sign, the equation, is perfectly okay as long as I do it to the other side. So if I am going to add a negative 6 on this side, I have to add a negative 6 on that side. And a positive 4 plus a negative 6 is a negative 2. Now, we can go over here and check this by taking our original equation, x plus 6 equals 4, and substituting, there we go again, the value for the variable, negative 2 in here. So negative 2 plus 6 equals 4, and that gives us 4 equals 4. And so our solution that we got over here does work. So remember, positive 6 is attached to the variable, and do it by adding a negative 6 to both sides. Okay, let's try a couple. X plus 8 equals 3. All right. My variable is located on the left. It is attached through addition to a positive 8. The inverse of a positive 8 is a negative 8. To both sides, draw the line all the way across. These are the things I'm looking for, and show me that it cancels. X equals a pot. Now I'm adding at this point. 3 plus a negative 8 is a negative 5. Check it. X plus 8 equals 3. Substitute in. Negative 5 plus 8 is 3. And that works. Look at example 2. 5 equals d plus 1. The difference with this one is the variable is on the right side of the equal sign. It's attached through addition to a positive 1. Inverse of a positive 1 is a negative 1. Add that to both sides. This cancels. D equals 5 plus a negative 1 is 4. And now we can check 5 equals d plus 1. And now substitute this in. 5 equals 4 plus 1, and 5 equals 5. Your solution is correct. And finally, example 3, c plus a negative 4 equals a negative 5. All right, so here's my equal sign. My variable is on the left. It's attached to a negative 4 through addition. The inverse of a negative 4 is a positive 4, again to both sides. And c equals a negative 1. Okay, let's check that and start with the original. C plus a negative 4 equals a negative 5, and c is a negative 1 plus a negative 4 is a negative 5, and that works. Let's take a look at example 2. This is a word problem. Fred's target heart rate is 130 beats per minute. This is 58 beats per minute more than his resting heart rate. And find his resting heart rate. So let R represent the resting heart rate. That's what you're being asked to find. Find his resting heart rate. So that's going to be our variable. Now if I go right here, from there to there, and I rewrote it, this is 58 beats per minute more than his resting heart rate. Okay, so what does that mean? This is what you're talking about here. His target heart rate, that's what this is referring to, is 130, is 58 more than the resting heart rate. But remember, that flips the order, that then. So it's 130 equals R plus 58. And now 58, well, first of all, the variable's on the right-hand side. It's attached through addition to a positive 58. The inverse of that is a negative 58 to both sides. Cancels. 130 minus 58 is 72 beats per minute. Okay, let's try one. Cora measures her heart rate at 123 beats per minute. This is 55 beats more than her resting heart rate, which is R. Write and solve an equation to find Cora's resting heart rate. So again, let R equal resting heart rate. And right here, this is 55 beats per minute more than her resting heart rate. So we're going to take that sentence. Do you need to recopy it? No, I've only been doing that to help you out. This, what are they talking about? This up here, okay? That's what her heart rate is. So this is the 123 is 55 more, than her resting, which is R. So the more than tells me to rewrite this and change the order, okay? So now what we're going to do is our variable's on the right side. It's attached through addition to a positive 55. The inverse of a positive 55 is a negative 55, and you do that to both sides and show me that it cancels. This line all the way across, this line going through, leaving you with the variable. Remember, that was our goal, to isolate the variable, and that leaves you with 123 minus 55 is 68, so the resting heart rate is 68 beats per minute. That's her resting heart rate. Okay, now let's take a look at subtraction. And if you remember, when we talked about integers, we looked at negatives a certain way. So let's take a look here. Okay, got it on there. Example 3. What's different here is that it's subtraction. B minus 12 equals negative 49. Now, if you remember, adding the opposite is the same as subtraction. So we are going to look at B minus 12 in a different way. We're going to look at it as B plus a negative 12. Easy. Now we're just going to do exactly what we were doing. All right, here's my equal sign. My variable B is on the left. It's attached through addition to a negative 12. The inverse of a negative 12 is a positive 12 to both sides. So the only difference here for subtraction problems is to rewrite them as addition. And that's what we've been doing so far. Every time we have subtraction, we rewrite it as adding the opposite. All right, so we get B equals a negative 49 plus positive 12 is make that a little bit darker, a negative 37. And then we check it over here. B minus 12 equals negative 49. B is a negative 37. So negative 37 minus 12 equals a negative 49. I look at that subtraction as adding the opposite. A negative 37 and a negative 12 is a negative 49. And it works. So let's try a couple. Okay, you don't need to rewrite this like I did up here. I like to write right over the problem. So y minus 5 equals 8. So that's the same as y plus a negative 5 equals 8. The inverse of a negative 5 is a positive 5 to both sides. Y equals 13. Okay, when you go to check this, y minus 5 equals 8. Substitute it in. 13 minus 5 equals 8, and 8 equals 8, and that checks. Look at this one. P minus 30 equals 42. So make that P plus a negative 30 equals 42 and add 30 to both sides. And P cancel equals 72. And now we check it. P minus 30 equals 42. P is 72 minus 30 is 42. And 42 does equal 42, and it checks. And finally here, my variable is on the right-hand side. 98 equals x minus 14. So think of that as x plus a negative 14. The inverse of a negative 14 is a positive 14 to both sides. And it cancels. X equals 112. All right, and now we take that one. 98 equals x minus 14. 98 equals 112 minus 14, and 98 equals 98, and it checks. Okay, let's try a word problem now. Your friend's DVD player costs $328 less than her TV. Her DVD costs $179. How much did her TV cost? So let T equal the cost of the TV. The cost of the DVD is $328 less than the TV. I took those words right out of the word problem. The cost of the DVD player, we know her DVD costs $179, so we put that in here, is 328 minus the cost of the TV, which is T, but the word then tells us flip it, so it's not 328 minus T, it's T minus 328. We write that as adding the opposite, adding a negative 328, and then you add a positive 328 to both sides, cancel, and the TV is $507. Let's look at the last one. A softcover book costs $17 less than the hardcover edition. The softcover costs $5. How much is the hardcover cost? So let H equal the hardcover cost. So now we know the softcover book costs $17 less than the hardcover edition. So if H is the hardcover edition, it costs $17 less than that. And we know the softcover book does cost $5. So if you take the price of the hardcover, take off the 17, you'll get the price of the softcover book. Now, add the opposite. So instead of subtracting 17, we're going to add a negative 17 and add a positive 17 to both sides. And the hardcover book is $22. And that's it. Good luck.